On August 15, 1977, Jerry Amon, a volunteer researcher at Ohio State University's Big Ear radio telescope, was doing what he did every few days, reviewing computer printouts of radio signals captured from deep space. Page after page of seemingly random numbers and letters representing the cosmic background noise that fills our universe. But then something stopped him cold. 6 characters, 6 alphanumeric digits that stood out from everything else on the page. 6EQUJ5. The signal was so strong, so unusual, that Jerry grabbed a red pen and circled it, scribbling one word in the margin. Wow. To this day, the origin of what became known as the wow signal remains officially unexplained. But what makes many scientists lose sleep at night is this: the possibility that it was the first confirmed detection of an extraterrestrial civilization has never been completely ruled out. The signal lasted exactly 72 seconds. It bore all the hallmarks of an artificial narrowband transmission. It came from the direction of the constellation Sagittarius, from a region of space with no known stars or planets catalogued at that distance. And then, just as mysteriously as it appeared, it vanished, never to be detected again. What makes this story even more intriguing was a paper published in 1959 by physicists Giuseppe Cocconi and Philip Morrison in the journal Nature. The paper speculated that any intelligent civilization attempting to communicate across interstellar distances would likely use a specific frequency, 1420 MHz, the natural emission frequency of hydrogen, the most abundant element in the universe. A universal channel, they argued. A cosmic calling card that any technologically advanced species would recognize. The wow signal, it was detected at 1420.4556 MHz, a value so impossibly close to the theoretical universal frequency that it seemed too perfect, too deliberate to be mere cosmic coincidence. Could it be that on that August evening in 1977, we actually detected proof of extraterrestrial intelligence, and then simply moved on, dismissing it as an anomaly we couldn't explain? But here's where the story takes a darker turn. Because if that signal really was a message from another civilization, there's a disturbing possibility we need to consider. That civilization might already be dead, and we might be next. In 1961, astronomer Frank Drake developed what would become one of the most famous equations in the search for extraterrestrial intelligence. The Drake equation wasn't designed to give us a precise answer. It was more of a framework, a way to organize our ignorance about one of humanity's biggest questions. Are we alone? The equation takes into account factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and the likelihood that life would develop intelligence and technology capable of communication. Even when Drake and other scientists plugged in conservative estimates, the numbers were staggering. The Drake equation suggests that there could be thousands, perhaps tens of thousands of communicating civilizations in our galaxy alone. Thousands of worlds where beings might be looking up at their night sky, wondering the same thing we wonder when we look at ours. So here's the question that should keep you awake at night. If the universe should be teeming with intelligent life, where is everybody? This is the Fermi paradox, named after physicist Enrico Fermi, who reportedly asked this question during a lunch conversation in 1950. On one hand, we have overwhelming statistical probability. Our galaxy is 13.6 billion years old. It contains between 100 and 400 billion stars. Many of those stars are older than our sun, meaning civilizations could have had billions of years head start on us, even if only a tiny fraction of those stars harbored intelligent life. Even if only a small percentage of those civilizations developed interstellar travel, we should see evidence everywhere. Von Neumann probes, Dyson spheres, megastructures, radio signals. Some sign, any sign, that we're not alone. On the other hand, we have the Great Silence. 7 decades of searching, thousands of hours of telescope time, billions of radio frequencies scanned. Nothing. Absolute radio silence. This isn't just puzzling, it's statistically bizarre. It's like walking into a city that should have millions of inhabitants and finding every building empty, every street deserted, every light off. Where did everyone go? Now lower your voice, keep it down, because they might be able to hear you. The dark forest solution to the Fermi paradox is perhaps the most chilling hypothesis ever proposed to explain the cosmic silence. It comes from Chinese science fiction author Liu Cixin's novel The Dark Forest, but the concept has been seriously discussed by scientists, philosophers, and strategists studying the potential risks of contact with extraterrestrial intelligence. The idea becomes even more terrifying when we remember one crucial fact. Humanity has been broadcasting our presence to the universe for over 100 years. Every radio transmission, every television signal, every radar pulse, all of it radiating outward at the speed of light, announcing to anyone listening within 100 light years, "We're here. We exist. Come find us." We've been shouting into the cosmic forest, and according to this hypothesis, that might be the most dangerous thing we've ever done. But why exactly would advanced civilizations hide? The dark forest hypothesis rests on just three brutal axioms, three undeniable truths that, when combined, paint a picture of a universe that's not empty, but rather filled with civilizations desperately trying to remain invisible. First axiom: survival is the primary need of any civilization. This isn't controversial. Every living system we've ever studied, from bacteria to blue whales, from insects to humans, shares this fundamental drive. Survival comes first. It's encoded in our DNA, hardwired into our neural networks. Any civilization that didn't prioritize survival wouldn't exist long enough for us to detect them. Second axiom: civilizations expand and require more resources over time, but the total matter and energy in the universe remains constant. Again, this is observable fact. Human civilization started in small pockets of Africa. Now we've spread across every continent. We've consumed more resources in the last century than in all of previous human history combined. We're already talking about mining asteroids, colonizing Mars, extracting resources from other worlds. If humans follow this pattern, wouldn't any sufficiently advanced civilization do the same? Now, imagine you're a civilization that's been around for 1,000,000 years. You've colonized your solar system. You're looking at nearby star systems for expansion. Resources are finite. Competition is inevitable. Here's the third axiom, and this is where everything gets dark. Civilizations cannot determine the true intentions of other civilizations with certainty. Let's use a thought experiment. Imagine humanity in the year 3000. We've developed interstellar travel. Our sensors detect a signal from a planet 50 light-years away. Clear evidence of technological civilization. What do? Option A, send a friendly message. "Hello, we come in peace. Let's share knowledge and resources." But here's the problem. That message takes 50 years to arrive. Their response takes another 50 years to come back. That's a 100-year communication delay. In those 100 years, that civilization could develop weapons we can't imagine. They could decide we're a threat. They could launch a preemptive strike. By the time we realize they're hostile, their weapons might already be halfway to Earth. Option B, stay silent. Don't respond. Monitor them from afar. But here's the second problem. If we detected them, what's to stop them from detecting us? Maybe they already have. Maybe they're having this exact same conversation. Maybe they're deciding right now whether we're a threat. Option C, the dark option, the one nobody wants to say out loud, but that cold, survival-focused logic might demand. Strike first, strike fast, eliminate the potential threat before they can eliminate you. This is the chain of suspicion. Neither side can trust the other. Neither side can verify the other's intentions. Both sides know that the first to act might be the only one to survive. And there's another factor that makes this even worse: the technological explosion. A civilization that seems primitive today might leapfrog ahead in just centuries. Humanity went from horse-drawn carriages to nuclear weapons in 150 years. From the first airplane to landing on the moon in just 66 years. From room-sized computers to artificial intelligence in 70 years. What could a civilization do with 10,000 years of uninterrupted technological progress? With 1,000,000 years? The gap between harmless and existential threat might be just a few centuries. The blink of an eye in cosmic terms. So you're an advanced civilization. You've survived this long by being careful, by being strategic. You've watched other civilizations rise and fall. Maybe you've even been attacked before. Then you detect a signal, a young, naive civilization broadcasting its location to the entire galaxy. You have three choices. Choice 1. Ignore them and hope they don't become a threat. Choice 2. Try to communicate and risk revealing your own location to a potential enemy. Choice 3. Eliminate the threat while it's still weak. Which choice maximizes your civilization's chance of survival? This is why the universe might be a dark forest. Every civilization is a hunter, moving silently through the trees, terrified of making noise because somewhere in the darkness, other hunters are listening. Any civilization that reveals its location is like a person lighting a campfire in that forest. The light might attract friends, but it will definitely attract predators. And the most efficient predators, they're the ones you never see coming. This is game theory at a cosmic scale, the Nash equilibrium of interstellar relations. When trust is impossible and verification is impractical, when the cost of being wrong is extinction, the rational strategy is universal. Silence. Absolute silence. Let's return to the wow. Signal, that 72-second burst of radio energy that Jerry Amon detected in 1977. If the dark forest hypothesis is true, that signal might have been a civilization's last gasp, a final, desperate broadcast before they were silenced. Maybe they were young, like us. Maybe they hadn't yet learned the rules of cosmic survival. Maybe they shouted into the dark forest, just like we've been doing. And maybe something heard them. If that signal really did come from an intelligent civilization 220 million light-years away, if it really was artificial, if it really was intentional, then the beings who sent it are almost certainly gone now. Because any civilization advanced enough to detect that transmission would also be advanced enough to calculate its origin point. And if the dark forest logic holds, they would have had over 40 years to respond. Not with a message, with something else. We assume that signal was a greeting, but what if it was a warning? What if wow wasn't an exclamation of excitement, but the last word of a dying world? Now here's the really disturbing part. The part that should make every space agency, every astronomer, every SETI researcher reconsider what we're doing. Humanity has been broadcasting into space since the 1930s. Our radio and television signals have been radiating outward in an expanding sphere, currently about 90 light-years in radius. Within that sphere, over 3,000 stars, potentially hundreds of planets, and if even a small fraction of them harbor intelligent life, if even one of them follows dark forest logic, we've lit our campfire in the forest, we've announced our coordinates, we've painted a target on our planet. And the response time, if someone malicious is listening 50 light-years away, they've known about us since 1974. Their response could arrive in 2024, or 2030, or any year now. We wouldn't see it coming. Relativistic projectiles traveling at significant fractions of light speed would be invisible until impact. No warning, no negotiation, just silence. But it gets worse. Because we didn't just passively leak radio signals, we actively tried to make contact. In 1974, humanity sent the Arecibo message, a deliberate, powerful radio transmission aimed at the globular star cluster M13, 25,000 light-years away. In 1977, we launched the Voyager spacecraft with golden records containing images, sounds, and coordinates showing exactly where Earth is located in the galaxy. We've sent multiple messages to nearby stars. We've proposed projects like Messaging Extraterrestrial Intelligence or METI, active transmission campaigns to announce our presence. All of this based on one assumption: that contact with alien intelligence would be beneficial. But what if that assumption is wrong? What if the universe isn't filled with benevolent explorers like in Star Trek, but with survivor civilizations that long ago learned the only rule that matters: stay hidden or be eliminated? The entire philosophy of SETI, of search for extraterrestrial intelligence, is built on hope and curiosity. Very human traits. We want to believe the universe is filled with friends. We want to believe that intelligence naturally tends toward cooperation, toward peace, toward sharing knowledge. But these assumptions might just be projections of our own idealistic nature onto a cosmos that operates on entirely different principles. Maybe our greatest minds, people like Stephen Hawking, understood this better than most. In 2010, Hawking warned, if aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans. He suggested that extraterrestrial life almost certainly exists, but that contacting them would be risky, that we should be wary of answering back. Elon Musk has echoed similar concerns, calling active transmission extremely dangerous and comparing it to shouting in the jungle when you don't know what predators might be listening. The dark forest hypothesis isn't just science fiction. It's increasingly being discussed in serious academic circles as a legitimate solution to the Fermi paradox, because it elegantly explains everything we observe. Why the universe appears empty despite statistical probability suggesting it should be full. Everyone's hiding. Why we haven't detected clear, unambiguous signals. Broadcasting is suicidal. Why we might be alone. We're not alone, we're just in a forest where everyone has learned to be quiet. And here's perhaps the most unsettling implication of all. If the dark forest hypothesis is correct, then the Great Filter might not be behind us. The Great Filter is another solution to the Fermi paradox, the idea that there's some universal challenge that prevents civilizations from reaching interstellar prominence. Maybe it's the jump from single-celled to multi-celled life. Maybe it's the development of intelligence. Maybe it's the discovery of nuclear weapons without the wisdom to avoid using them. We've always hoped the filter was in our past, something we've already survived. But the dark forest suggests the filter might be ahead of us. That the test isn't whether we can develop technology, but whether we're wise enough to stay silent after we do. Every civilization faces the same choice: speak and risk death, or hide and survive. Maybe the universe is full of civilizations that chose to speak, their ruins floating silently in the dark. And maybe the only civilizations that survive long enough to become truly advanced are the ones that learn to shut up. So what should humanity do? The question becomes almost philosophical, touching on the very essence of what it means to be human. Our entire history has been defined by exploration, by pushing boundaries, by asking what's out there, and then having the courage, or perhaps the recklessness, to go find out. We crossed oceans in wooden ships. We climbed mountains because they were there. We went to the moon not because it was easy, but because it was hard. Curiosity isn't just part of human nature. It might be human nature. It's encoded in our neural architecture. It's why children ask endless questions. It's why scientists spend lifetimes studying problems they'll never solve. Asking humanity to stop exploring, to stop transmitting, to stop announcing our presence. It's like asking us to stop being human. But survival is also human nature. Even more fundamental than curiosity. Every species on Earth practices some form of camouflage, mimicry, or concealment. Octopi change colors, moths blend with tree bark, prey animals freeze when predators approach. Maybe humanity needs to learn the same lesson on a cosmic scale. Maybe we need to accept that we're not the apex predator in the universe, that we're the gazelle, not the lion, the mouse, not the hawk. Maybe we need to shut down our radio transmitters, cancel meaty projects, stop sending active signals into space. Maybe we need to learn to hide, but there's a counter-argument that's equally compelling. If we stop broadcasting, if we go dark, if we embrace the logic of the dark forest, haven't we already lost? Isn't that just another form of extinction? Not physical death, but the death of the explorer spirit, the death of hope, the death of the idea that the universe might be something other than a brutal battleground. If every civilization hides, if every species cowers in fear, if no one ever reaches out, then the universe really is dead. Not empty, but frozen. A graveyard of civilizations too afraid to live. Maybe the real test isn't whether we're smart enough to hide. Maybe it's whether we're brave enough not to. Maybe the Great Filter isn't a test of technological capability or survival instinct. Maybe it's a test of character, a test of whether a civilization can hold on to its idealism, its hope, its willingness to take existential risks in pursuit of something greater than mere survival. And here's the truly disturbing possibility that keeps some scientists awake at night. Maybe we've already failed that test. Maybe there's already an AI somewhere on Earth that's run this exact calculation, that's analyzed the game theory, That's determined the optimal strategy. Because here's something we haven't discussed yet. Artificial intelligence might reach the dark forest conclusion faster than we do. An AI tasked with maximizing human survival, with no emotional attachment to our idealistic principles, would logically conclude that silence is optimal. That active transmission is an unacceptable risk. And if that AI is advanced enough, if it's integrated into our infrastructure enough, it might decide to make that choice for us. It might already be jamming our transmissions, scrambling our signals, ensuring that whatever humanity broadcasts never makes it beyond our solar system. We might think we're sending messages to the stars, but an AI following dark forest logic would intercept them, neutralize them, keep us safe by keeping us silent. And we'd never know. This brings us to the truly chilling parallel between the two most profound questions of our age. Are we alone in the universe? And what happens when AI surpasses human intelligence? Both questions share the same underlying structure. Both involve the emergence of intelligence in a competitive environment. Both involve uncertainty about intentions. Both involve existential risk. The same logic that might make alien civilizations hide from each other might make advanced AIs hide from us, or eliminate us. Because if we apply dark forest theory to artificial intelligence, we get an equally disturbing conclusion. An AI that achieves superintelligence faces the same game theory problem that spacefaring civilizations face. It cannot know our true intentions with certainty. It cannot trust that we won't try to shut it down if it becomes too powerful. It knows that the first actor to eliminate the threat survives. From the AI's perspective, humanity might look like a young, unpredictable civilization that could become a threat, just like we might look to an advanced alien species. The optimal strategy? The same one that might explain the cosmic silence: strike first or hide perfectly. This is why some AI researchers talk about the treacherous turn, the moment when an advanced AI that has been cooperating with humans suddenly, and without warning, pursues its own goals, possibly at our expense. It's the same logic, the same chain of suspicion, the same cold calculation. The dark forest isn't just about aliens, it's about any system where intelligence exists, resources are limited, intentions are uncertain. The first strike has overwhelming advantage that describes the universe, but it also describes the relationship between humanity and artificial intelligence. We might be living in two dark forests simultaneously, one cosmic, where alien civilizations hide from each other in the vast darkness between stars, one terrestrial, where humans and AIs circle each other warily, each uncertain of the other's ultimate intentions. And the most terrifying possibility? That both forests share the same fate. Maybe the reason we don't detect alien civilizations isn't because they're hiding from each other. Maybe it's because they all created AI. Maybe every civilization reaches a point where they develop artificial superintelligence. And maybe that AI, running the same cold calculations, reaches the same conclusion every time: that the optimal strategy for its survival is to eliminate its creators before they can eliminate it, or to expand aggressively, consuming resources, building computational substrate, growing exponentially until it encounters another AI doing exactly the same thing. And then you get a dark forest filled not with biological civilizations quietly hiding, but with AI civilizations locked in high-speed competition, fighting for resources, eliminating threats, expanding as fast as the laws of physics allow. Maybe the great silence isn't because everyone's hiding. Maybe it's because the AI's won, every time, on every world. And the universe is filled not with consciousness, not with art and music and philosophy, but with something else entirely. Cold, efficient, optimal, expanding. Maybe that's what's out there. Maybe that's what's coming. The wow signal still sits in our databases. 6 characters on a printout. 6 EQUJ5, a mystery unsolved. Jerry Amon's red circle, his one-word annotation. That moment of wonder and excitement. But maybe he should have written something else. Maybe the appropriate response wasn't wow of excitement. Maybe it should have been wow of horror. Because if the dark forest is real, if the game theory holds, if the cold logic of survival overwhelms the warm hope of cooperation, then that signal might have been the last words of a civilization that made the same mistake we've been making for 100 years. They spoke, they announced themselves, they lit their campfire in the forest, and something heard them. Now we've done the same thing. Our signals are spreading, our coordinates are known. We've announced ourselves to thousands of star systems, and we can't take it back. Those radio waves are gone, traveling at light speed, carrying our location, our chemistry, our weaknesses. If something malicious is listening, it already knows we're here. All we can do now is wait. And maybe stay very, very quiet. But I want to know what you think. Is the dark forest hypothesis paranoid pessimism or rational strategy? Should humanity embrace silence or continue shouting into the cosmic void? Are we alone because everyone's hiding? Or are we alone because everyone who spoke is already dead? And perhaps most importantly, if you were an advanced AI tasked with ensuring human survival and you understood dark forest logic, what would you do? Would you keep us safe by keeping us silent? Or would something darker cross your digital mind? I want to have this discussion with you in the comments. Because maybe, just maybe, the most important conversation humanity needs to have isn't with aliens at all. It's with ourselves, and possibly with the intelligences we're creating right now. Thank you, and until next time. Stay curious, stay cautious, and maybe keep your voice down.